carboxylic acids and esters. Half of the chapter will be, the first half, we'll just be getting familiar with what are carboxylic acids. And then as soon as we start talking about how do they react, what are some of the reactions carboxylic acids undergo, we're going to be in the realm of esters. We're going to be producing esters from them.
Thank you.
You are very, very familiar with this carboxylic acid. This is a carboxylic acid, and it's in vinegar. It's acetic acid. Carboxylic acids are weak acids. They don't dissociate entirely in water. Matter of fact, they only dissociate a little bit, but enough to give you that tingly taste on your tongue, to lower the pH to about 3, to make the water acidic. Acetic acid. So it's very, very common carboxylic acid. I would guess the most common carboxylic acid. So what are carboxylic acids? The functional group is the carboxyl. The carboxyl group, usually if you were seeing it in a condensed formula, it'd be COOH. If you see it drawn out structurally, it's a carbon-oxygen double bond, and on that same carbon is a hydroxyl group. Earlier on, I think in chapter 13, we showed you a molecule that had maybe an OH group over here and a carbon-oxygen double bond over here. That's not a carboxylic acid. That's an aldehyde and a hydroxyl on a molecule. Carboxylic acid has all of that on the same carbon, and it's always at the end of the molecule. Perhaps the most common one is acetic acid. Citric acid in lemons and limes. Apples contain malic acid. These are all naturally occurring carboxylic acids. And they're all weak acids. All right, here's the general formula. Here's your carboxyl group with an R here being whatever. Here's, again, acetic acid that's in vinegar. Vinegar is about 5% acetic acid, 95% water. You can buy pickling vinegar. It might be 9%. 9% or 10% acetic acid. This is a common name. Here is the IUPAC name. And you should pick that out. I mean, eth means 2 carbons. We've got 2 carbons. 2 carbons on there, so it's eth instead of ethane, ethanoic acid. These are very polar, more polar than alcohols. These carboxyl groups. Okay, 3 carbons long, propanoic acid. Propanoic acid. It's always on the end. The carboxyl group is always on the end. This is your acidic hydrogen right here. You put that in water, and you put this in water, and you'll get this. Let's go back to the second one. Right here, you put this in water, and you'll get this plus the hydrogen ion, which makes the water acidic. All right, so these other hydrogens don't come off. They don't come off in the water. And even if you had this molecule, which is in the alcohol that's in alcoholic beverages, when you put ethanol in water, this hydrogen does not come off of that oxygen. that molecule just dissolves in the water. You check the pH, pH really hadn't changed. It's 6, 7, or 8. It's pretty neutral. Why? Because that hydrogen is not a dissociatable hydrogen. It doesn't come off of the oxygen. But when you get a hydrogen over here and you get all this oxygen here, you now get a situation where this can be teased off of there by the water, and you'll form the negative ion and the hydrogen ion, and that's what makes it acidic. All right, and so we're saying they're polar. Again, let's take a peek at, there's two containers here kind of simultaneously. Over here is just a carboxylic acid, anhydrous, no water, totally dry. Well, the oxygen on the carboxyl group can hydrogen bond to the hydrogen on another carboxyl group, vice versa. And the carbonyl can hydrogen bond to the OH on another carboxylic acid molecule. So you can get a lot of hydrogen bonding. So this group right here is very polar. So water as well would love to hydrogen bond with these molecules. Always the negative oxygen presenting itself to a positive hydrogen. So this is the carboxyl group with some water added to it. Okay. Your least favorite slide. Keeps coming up. But we never got, here's our carboxylic acid here. So let's take a look at it again. Here's your alkane. Approximately 0 degrees centigrade, boiling point. Here is your aldehyde, approximately 50 degrees. Ketone, approximately 50 degrees. Let's just lump those together. Here's your alcohol. We've seen all this before. Approximately 100 degrees. And now here's our carboxylic acid. Higher boiling point yet, 120. And what do we keep in constant? About the weight of the molecules. We're comparing comparable molecular weight molecules and seeing dramatically different boiling points. Why? Because of how much attraction there are between the molecules themselves. Higher boiling point, more attraction. So there's a stronger attraction here for ethanoic acid molecules to one another than there is over here with alkanes. Very low attraction. All right, we already said alcohol is pretty strong, pretty high boiling points. Well, the carboxylic acid is higher yet. Your chapter 14 homework is going to have 3 or 4 cases where it says, compare this molecule to this molecule. Which one do you think would be more soluble in water? Okay, this doesn't have solubility, but the higher the boiling point, the more polar the molecule is. The more polar the molecule is, the more soluble it'll be in water. That's what's going on here. More polar, stronger attraction, stronger hydrogen bonding. So the more polar, stronger these attractions are, and so more polar, and therefore the more it would dissolve water, or water would dissolve in it. So that's what to keep in mind. Maybe when we hand it out, we'll take one of those cases. Nomenclature. Okay, we're going to find the longest chain that has the carboxyl group in it 4 carbons long, butane. I'm going to drop the E and add oic acid. Butanoic acid. So we add the word acid to it now. It's butanoic acid. And then we pick up this bromo group, 3 bromo butanoic acid. Like the aldehyde, we don't have to put a 1. We don't have to say what carbon the carboxyl group is on, because it's always going to be on the end. If there are 2 carboxyl groups, it would be a dioic. Butane dioic acid. Let's see if we have a dioic anywhere. Yeah, here's propane dioic acid. 3 carbons long, carboxyl group on both ends of the propane. So it's propane. We're going to keep the E. If it was only 1, we'd call it propanoic acid. But there's 2, so we keep the E just so we don't have an N and a D sitting right next to each other. Trying to figure out how to pronounce that. So it's propane dioic. Here you can see these common names: malonic acid, adipic, acetic, propionic, beta-methylbutyric. All right, here's a slide. This is your 3x5 card roundup. 3x5 cards for this, 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 and this. This and this. Let's kind of look at them. Okay, just 1 carbon. The top one there is just got 1 carbon. So this is kind of what it looks like. That's formic acid. It's got a COOH, a carboxyl group, and that's only 3 bonds. So there needs to be something else, and the 4th thing is another hydrogen. Okay, if you ever get bitten by fire ants, have ever gotten bitten by fire ants, or intend to in the future, then you'll be glad you stayed today, because here's the anecdote to it. What do fire ants do? They bite you and they leave behind a little bit of formic acid, which, could you imagine having a little scratch and you're rubbing acid in it? Itches terribly. So you go inside and you get some baking soda. That's a weak acid. You get some baking soda, put it in water, which is a weak base, and rub it on where the fire ants have bitten you, and the baking soda will neutralize the formic acid and take away the itch. I don't know if it works, but if I convince you of that, you'll think it'll stop itching. Just because major psychological effect on you. The itch will go away. All right, so that's formic. And I don't know. So formica is Latin for ant. All right, so they figured this out. I guess this is where we get that root word. So form often is going to mean 1 carbon. You've already seen formaldehyde. All right, there is some system even to the common names. Formic acid is a common name. Form, 1 carbon. Formic acid. Formaldehyde, it's a 1 carbon aldehyde. This is formaldehyde. That's not 14, that's a hydrogen down there. So formaldehyde, and then in chapter 15 you're gonna come across formamide, a amide with 1 carbon in it. So form is coming back again and again. Acetic acid. So your 3x5 card should have the IUPAC name and the common name, and then the formula. So acetic acid, and I wouldn't just do that formula, I would do a formula like this. You know, really kind of lay out what the formula, structural formula is of that molecule. Propanoic acid is also called propionic. Butanoic acid, that's the IUPAC name, is also called butyric. And if butter goes bad, it forms butyric acid. That's rancid butter.
The name in the parentheses is the IUPAC name?
Yeah, in the parentheses is the IUPAC name, and the one that's not in parentheses is the common name. Okay, now down here, these are fatty acids. Let's just say that. This is a fatty, this is a unsaturated fatty acid. And stearic acid is a saturated fatty acid. I'll just abbreviate it, FA, fatty acid. Okay, stearic acid. It comes from beef fat. So I don't know why they spell it that way. They should have spelled this stearic acid. I don't know why. They come up with STEARIC. But stearic acid from steers or beef cattle is that's what one of the major fatty acids in beef fat. Citric acid. Okay, here's a carboxyl on the end. The carboxyl on the end. There's another end. So we kind of got three. Or a side there, carboxyl group, that's citric acid. Lactic acid, adipic acid. So lactic acid is in yogurt, and lactic acid is in your muscles when you've exercised real hard. Form a lot of lactic acid, makes your muscles sore. All right, let's name a couple of these. Don't worry about the bottom one. Well, yeah, we'll try it. Yeah, name these two. Name these two top ones. I'll take volunteers who want to holler out the name. What's the longest chain on the top one? Five? 1, 2, 3, 4. So pentanoic. Pentanoic acid. Well, I numbered them the wrong direction. This is carbon number 1. Two bromo 4-methyl. Okay. How do we like that? 2-bromo-4-methylpentanoic acid. Okay, yeah, we're going to start numbering right here. 1. So what's the parent name of this next one? Octanoic. Octanoic acid. What's the rest of the name? 2,5,7 tribromo. Tribromo octanoic acid. Okay, well, this one, the one down here on the left, we have a saturated 6-membered ring there. What would we call it without the carboxyl group on it? Cyclohexane. So we would drop the E and call it cyclohexanoic acid. We just follow our rules there. This is going to be cyclohexanoic acid. Now this one here, we cut it down a little bit. We just call this benzoic. It is benzene with the carboxyl group on it, so you think it might be benzenoic, but it's just benzoic acid. Benzoic acid. And this is benzoic acid. There's nothing different about those two. Just different ways of representing the benzene ring. So that's benzoic acid. Some important fatty carboxylic acids. Fats, we will study in chapter 17, or lipids. We will use the words interchangeably. Lipids basically are molecules that are not soluble in water. And these fatty acids have such a long non-polar chain. Let's see, let me blow this up a bit. Okay, here's your stearate ion or stearic acid. You'd have a hydrogen right here. Yeah, that's very polar. I just told you that carboxyl group is very polar. But there are 17 more carbons here. 17 that are nonpolar. So this tail of the fatty acid is not water loving. It's not soluble in water. This little head over here will gravitate towards water, but not enough to drag that whole molecule into the water with it. Okay, so they're fatty acids. They're molecules that have a hydrophilic head and a hydrophobic tail. So that's stearic, and it's saturated. Here's oleic in olive oil, and it's unsaturated. It's got one double bond in it. And these double bonds are always cis. You see how come along here, come into the double bond, you come out the same side, and that molecule has a kink in it because of that cis configuration of that bond. So there's stearic acid, oleic acid. I don't know how well you can see that, but we've got a CH3, and then they're just CH2. There's 16 of these, and then there's a carboxyl group. So that's a condensed way of writing stearic acid. Oleic acid, there are 7 of these CH2s. Then there's the double bond. Then there's 7 more of them. And then there's the carboxyl group. Hopefully I got that right. 7 plus 7 is 14, 15, 16, 17, 18. Each one of these are 18 carbons long. Stearic and oleic. They're 18 carbon long fatty acids. But the big difference is oleic has 1 double bond in it. It is the unsaturated fatty acid. Okay, let's see. Where are we? Oh, that's 1107. May 21st, we were to finish chapter 13 and start chapter 14. Tomorrow we will try to finish chapter 14. Let's get this, I want to get this homework in your hands, and let's take a look at this one that has to do with solubilities and think about one of these. Chapter 13 homework will be due tomorrow. Chapter 13. Sure. Everybody get one of these? Again, I don't think you could do the first page, the front page of this. From what we've discussed so far, you could at least do the front page. Take a look at problem 1. And you see the way we paired things up there. It says, which member in each of the following pairs has the higher boiling point and why? It may help to draw the structural formulas. Another way of asking that question is, which of these two molecules, like look at 1A, we got hexanoic acid and heptanol. Heptanoic acid and heptanol, we've got an alcohol and a carboxylic acid. Another way to ask that question is, which one of those two molecules is the most polar? The one that is the most polar will be more strongly attracted to itself through hydrogen bonding and therefore have the higher boiling point. So it's the alcohol versus the carboxylic acid. And this is the slide that helps you ferret that sort of thing out. Now, we don't have heptanol or heptanoic acid on this slide. We have propanol and ethanoic acid. we've got a carboxylic acid, comparing it to a alcohol. So that's the kind of comparison you need to make. What class of organic compound has the stronger, is the most polar, and therefore going to have the stronger hydrogen bonding? I'll let you think about that. Okay? Think about that. And then 1B is comparing an aldehyde to an alcohol. And then 1C again is comparing an alcohol with a carboxylic acid. All right, and then problem 2 is drawing certain. You can't do all of those. You could do you could do some of those, because 2B is an ester. We haven't gotten there yet. Okay, so you really can't. We'll talk about esters tomorrow. But you could do 2A, D, and E. You could at least think about those. The rest of them are esters. 2B, C, F, and G are esters. So we'll get to it, and these will probably be due on Wednesday. So let's see. Today's Monday, and Tuesday we'll finish chapter 14. Wednesday, I don't know. I think Wednesday we'll finish chapter 14 and maybe even 15. Thursday, be ready for an exam on Thursday? Kind of rough to talk about an exam on a day when you just had an exam, isn't it? I mean, we could start chapter 16 on Thursday and have the exam on Friday or something like that. But let's see. Well, let's talk about it tomorrow. Finish your chapter 13, and we'll finish chapter 14. You'll be able to finish that tomorrow. Turn it in Wednesday. All right. Go home. Refill your heads. Yeah. Let me just save.